Hello, everybody, and welcome back to Stationeers. Oh crap. I'm gonna have to set up a bit of an extra set of instructions for that. Sorry. So, welcome back to Stationeers, where I've been messing with the IC10 and trying to do some stuff. Now, I put out a 0.5 episode in the pretty much right after the last episode, which I believe was 16, where I kind of messed around with some stuff in the background and did some rearrangement. So you're going to see that the wires are a little different, and you know, we got transformers in different places and stuff like that. And part of that was me just trying to kind of clean some stuff up because I wanted to do more IC10 work with the atmospherics and trying to get all that through with just the amount of devices that would have been on here would have kind of been a bit of a pain. Although now that I've learned how to do hashing, that doesn't matter. But yeah, the 0.5 episode, which would have been, I think, 16.5, it's just me kind of doing a little bit of a grind in between. Where I know some people just kind of want to get to the meat and potatoes of it. And some people are okay with watching the kind of the dirty deeds that have to happen in between, right? Getting your hands dirty and get it all done. So I'm going to keep doing that from now on. So whenever I'm doing stuff in between, I'll go ahead and record it. I'll put it as a 0.5 episode. If you like watching all of it, you'll watch that 0.5 episode. And if you don't, then you kind of skip the 0.5 episode. But I was able to finally figure out how to get this IC10 working the way that I wanted. So part of what I wanted was the moment that there was any kind of presence of nitrogen in the exhaust system, I wanted for the machine, so long as it was turned on, it would start running and it would turn on these volume pumps. Unfortunately, excuse me, give me 1 second. Unfortunately, it was kind of hard to get that to work the way that I wanted, because the moment that I would shut off in the last way that I coded it, the moment that I would shut this off, or the moment that it would shut itself off, it would shut the pumps off. Well, I found that there's, rather than doing the on state, there's the setting state. The setting is either operational or in standby. Standby being 0, operational being 1. And so long as you have this turned on, it'll read what's in this input as a ratio, and it'll set itself to on if there's nitrogen in it. And the way that looks is, if we go in here, let's go ahead and write this up, edit. So again, I learned how to do hashes. So you define your device types, right? So you got a filter device, this hash, which is the filters that are there, the pump devices, which are the 2 volume pumps. And then you can name them custom names. And in this case, this filter is named the nitrogen filter or N filter. These pumps, this is the standard pump. So it's the nitrogen pump, and then this is the nitrogen exhaust pump. And then you go in here again. So we've named those. I've defined a cut on rather than a cut off. So if the volume or the ratio of nitrogen to everything else is greater than 0, meaning if there's nitrogen in that valve or in that pipe, we are going to, so the cut on is 0. So if any nitrogen is in there, we're going to turn on the cut on. I've set the aliases, so device states, gas ratios, all that stuff. And then I've set the device state to 0 from the get-go. When the main runs, we're going to wait for a little bit, and then we are going to set our batch, or set our device filter to setting. And it's going to be whatever the device that is, which is right now it's 0, so it's in standby. We're going to set batch of pumps to the device state, which is 0, and then the exhaust pump, which is 0. So these are your what the device is, the device type, and then this is what it's named. So this one's named filter, this one's named pump, this one's named pump exhaust. These are all being set to 0 right now, right at the beginning. Then we're going to check. So I'm going to load from batch named filter. I want to load into the register 0 called gas ratio from the filter device named filter, what the ratio nitrogen input is, and it's a batch, what's it called? Batch mode of 3, so whatever the maximum is. Then here's where our if statement comes in, right? If we're going to branch, if greater than. So if the gas ratio that we just pulled here is greater than the cut-on being 0. So if the gas ratio is greater than 0, we're going to run. And then we go down here, we'd move device state to 1, meaning we would turn on the device states, we'd back jump to main. And then here we would be setting all the devices to on. The setting of this device would be 1, and these pumps would be turned on. If the, excuse me, if the gas ratio is not greater than the cut-on, then we set the device state to 0 and we jump back to main and we check again. Okay, this is our loop here. Now, something that I just noticed is you can get a bit of a cutoff before, or you can turn off the pump exhaust before it's emptied. So what I want to do is when I set this device state to 0, I want to also run a bit of a different rather than jumping to main. Well, I basically want to set a timer. We're going to set all the devices to 0, and then we're going to run an end command. Don't know if this is going to work, but I'm going to try it anyway. So end, oops, end, okay. And the end command, we are going to going to, is it pause? No, not pause. Wait. No. Damn it! What's the? It's not yield. Not hold. Sleep. I want to sleep for, let's say 30 seconds. Then we jump to main. Okay. Do this a little differently. Let's what can I read from the volume pumps? I'm sure I can read something from the volume pumps. Let me see. Volume. Okay. We can read inputs. Maximum power error setting on reference IDs. Ratios. Okay, so we can't, but I think from the filter we can read the output. Let's see. Can we read the output? Pressure input. It's ID ratio. There's an output read. They're just ratios right now. Pressure output. Okay. But I can read pressure output. So do it a little bit different. So then let's do branch greater than. I'll have to load that too. Let's do load batch name. I'm gonna do another alias, exhaust, enter. Readable, exhaust pressure to R2. So, to exhaust. Sure. On the filter device with the name filter. Logic type is pressure output. Batch mode is 3 for maximum. Okay. I'll do this to clean up this code a little bit. So, if branch greater than, if exhaust pressure is greater than 0, it's fine. Did you do a sleep here? You can't. What do I want to call this? Sure, we'll call it int. So what are we doing here? We're still doing the same thing. If gas ratio is greater than the cut-on, we're going to run. Then we would go run, move device states to 1, go to main, do it again. If not, then we're going to run the next branch, which if branch is greater than, if the exhaust pressure is greater than 0, we're going to end. And in end, we're going to sleep for 30. And then we're going to do this. Copy. That. Not. We're going to set move. Not an M. Move. Device state to 0. And let's see. So we are setting all this up, going into main. We're going to set all our devices to be off, or we're going to set our device states, which right at the beginning is going to be off. Then we're going to load from the filter what the nitrogen input is reading. If the nitrogen input is greater than the cut-on, we're going to run. If it's not, we're going to check our exhaust pressure. If the exhaust pressure is greater than 0, then we're going to run the end command, or the end. If not, we're going to set our device states to 0 and then jump to main, wait, and then run it again. But if we do run, we'll set our device states to 1 and then jump to main and check again. If our exhaust pressure is still high, then we will run the end command. And the end command, we're going to sleep for 30 and then run another check on the exhaust pressure. If the exhaust pressure is still greater than 0, we're going to sleep for 30. Once the exhaust pressure is no longer greater than 0, then we're going to set the device states to 0 and then move to main. Now, the one thing that I do have to check is there a output number? Let me see. Output, total slots. As far as I can tell, there isn't. It's just output. No, ratio oxygen output 2. Total moles output. So there is an output 1 and output 2. Pressure output. Pressure output 2. Okay, so I need to find out. This is output. This is output 2. Unfiltered. Oh, hold on. Unfiltered. Show on. Pressure output. Pressure output 2. Can I take this pipe out and put it back in? I just thought about that. What's stopping me from doing that? Not stress anymore. Okay, I'm pretty sure that's output 2. I might have to combine the two. So check both, add them up, and then do the branch. That way the pumps will continue to run until there is no more pressure. It's kind of a bit of a check on both. I would have to run this check too at end. Isn't that how is it supposed to know, right? It's not checking this again. Copy. Sleep for 30. And check it again. No. No. Copy. Paste. Copy. Paste. How it's defined in the stupid thing? Yeah. Exhaust pressure output 2. Mhm. To register. Okay. So we're going to add onto total pressure. Copy, paste, copy, paste. Okay. Add into total pressure the exhaust pressure of 1 and 2. If branch greater than exhaust pressure, total exhaust pressure, or total pressure is greater than 0, I'm going to go to end. And then here, I hate that I can't copy like more than one. It's so annoying. Copy. Actually, I already have that one technically. Need to copy. Paste. And checking for add function again. And checking for blood pressure. Is this technically define? I think I can do the total pressure as a define without using another registry. So let's run this down one more time. Alrighty, coming into main, we're setting our device states. If we're going to pull down our gas ratio, if our gas ratio is greater than our cutoff, we're going to run. If not, we're going to check the exhaust pressures, combine them. If our exhaust pressure is greater than 0, we're going to run end. If not, we're going to set our device states to 0 and then back to main. If we're running, we're setting our device states to 1 and jumping to main. If we are ending, we are sleeping for 30. Then we're going to check our device pressures, combine them. If it's greater than 0, we're going to do it again. If it's not, we're going to set our device state to 0 and go back to main. I think that this should work. We're about to find out, aren't we? Going to put a little more nitrogen there real quick. Should be able to see. Yeah, there's nitrogen there. Cool. Nothing in there, nothing in there. I didn't put that many moles in there, so I'm hoping it's going to be a little bit quicker than last time. At least that's the hope. The key that I want to achieve here is I want to be able to turn all 3 of these on. And whenever I turn this on and I flood the pipe with stuff, it'll just do its thing. Or I can turn this on, right? And even if I forget about it, the system will not break, and I can walk away and then come over. Oh crap! I forgot to turn this off. That's right. I'll turn it off right now. Like, I'm still okay with having a little bit of manual intervention, but I would like it for it to be a little bit more fail-safe than just me forgetting to do something and then completely destroying my setup. If that makes any sense. It's fine. I do find it kind of amusing that this is coming in at 8.1. This is still not coming in any colder. All right, let me see. We don't have any liquid in the system, so that's still okay. All right. So I'm going to assume that that's going to run right now, and it's going to be perfectly fine just for a little bit, because I want to start setting this side up now. So this side up, I've gotten... this was for me to test the switches and stuff and see if I can get the alias to work. But this side here... Oh. Okay, so see, this right here is a problem. There's still pressure in the system. So there's no reason why this should be turned off. Right? So somewhere along the way, this is failing. Oh, where's the stress? Why are we stressing? Do a quick save. I'm stressed out. You do have 50 megapascals in there. So for some reason, that didn't stay on. Cut it off. Why would you shut off? Especially since it seemed like the thing was turned on. Did you go into end for some reason? I have to turn this off immediately. Let's see. Can I do that? I'm going to go into end. Set badge. Device filter. Setting. Sleep. Check. Run. Sleep. Check. Run. Sleep. Check. Run. Sleep. Check. And switch. Oh, it needs a wire, dum dum. I'm working. Sure. This power to 0. Let's switch to 1. Mhm. Switch to it. Open. On 0. Back to the direction. Action. Wait. Load. Direction. Wait. Direction. Open. Set power vent on. Set power vent. Mode. This mode. I shouldn't put that much nitrogen in there. I just thought about that. Well, I don't want too much nitrogen. I want actually quite a little bit of nitrogen. just to make sure that I'm not screwing something up. I'm going to switch that. I'm going to switch that. At 3.68 moles. There. So 1.53 moles. Okay. Okay. It's still doing it. So, for whatever reason, it's setting itself to stamp, but it's turning these off too. So something in my code somewhere is acting a little funky. Switch control. Can I rename this? Probably not. Power bench. Control. Main. Wait. Set the device states. Ratio nitrogen is higher. And hit run. Main. Turn this device on. Check again. Turn devices on. Check again. Check. So the gas pressure is not greater than the cutoff. I'm going to check pressures. Your total pressure. This is a define. As a sanity check. And I think that's how that's supposed to work. So we define total pressure as 0. We go in here. We're going to add register equals A plus. So exhaust pressure 1, exhaust pressure 2. Reading both. Exhaust pressure 1, filter device, filter, pressure output. Exhaust pressure 2, filter device, filter, output 2. Add it, get the total pressure. If the total pressure is greater than 0, we go to end. And end, we are going to set our filter device's setting to 0, and then we're going to sleep 30. Then we're going to run to this again. Add this together. And check. If it's greater than 0 again, go back and check. If it's not, then we're going to move all devices to 0 and then go back to main. So this should be okay. Maybe it's because I was using a register instead of define. Let me see. There's not anything in there. That's fine. Variable 124. Incorrect variable at line 24. Yeah, I think total pressure has to be. Register. Oh, you know what could be happening? I think I know what's happening. So what's happening is the moment that we do this check, so we combine these two, we add them together, we check this. Because the it's giving it like a false narrative almost. Unless the pressures are not what I think they are. Which is, very possible. Let me see something here. So fast. Oh, let me keep that on. Okay. I have some pipe in here. Right, no, there's no pressure in there. There's pressure here though. So switch states. Pressure input. Pressure output. Yep. Incorrect variable line 24. This is not changed. Okay, something else broke now. Wasn't turning those on at all. Not at all. Let's have a say. Some really weird, like, edge cases. See that? It turned the pumps off and kept this running. God damn it. What am I doing wrong here? I guess this technically doesn't do anything. Damn it. Another register.
Hydration critical.
I think I need to add a yield. Or does this? Okay, come on. Oh, still running. I don't get it, man. It's still doing that. It's keeping itself on. Obviously, I'm missing something, which I'll have to keep messing with until I figure it out. But this filter setting to stop, which would be 0, right? Because we set that up here, 0. Sleep for 30. I think is why are these guys like, you know, why is that still turning on or staying on? It's so weird. You know something that I hadn't thought about? I don't think that's the case, but these screws are still technically. It's not supposed to matter, but you know, just in case. Well, a lot more was supposed to happen today. As you can see, this still needs some work. I was supposed to set this thing up with some volume pumps, and that never got done. Unfortunately. What else? What else? Let me check my F8 list. Do auto cooling, that's done. Better Atmos, that still needs to be done. Upgraded solar, that still needs to be done. Recycler trader, remove furnace. Let's do this real quick. I'm actually going to be getting rid of this fridge and then putting the big one in. Which actually, now that I think about it, means I'm going to have to move that shelf. Which, what else is new? And the reason I didn't put it there is because it clips through the wires and it causes issues. If I remember correctly. So, yeah. Okay, let's do our fridge swap. I'm going to swap this fridge out. First thing I gotta do is compress this pipe. Let's go. Excuse me. I have another problem. Yeah. I'm gonna put this in here with that in there. Me thinks I have a problem. You served me well. Now you must be different. Yeah. Wires are all in the way. And so is the, this thing. Yep. Damn it. Oopie. This that totally doesn't have to be separated with different wires. I'm just being extra. Seriously? I'm confused as to why it was bugging me. Alright. Let's have power now. Let's real quick. See what the heck I'm doing. I must be able to see. Pretty sure. Hmm? Where's the floor potatoes? Where did I put the potatoes? Oh, I was very, very hungry. Oh, oop. Actually, that's perfectly exactly where it is. This one's the one that's going to be a problem. So, what we want to do is what's the rest of my volume pumps? Just have to do this. Uh, What is the other freaking pump? There's the pressure regulator, which is not what I'm looking for. There's the volume pump. There's supposed to be 2 volume pumps. The mirrored volume pump. Turn them on, but we are going to power them. Whatever that means. Pipe analyzers, thank you. Yep. Look up the pipe analyzers. Alrighty, so I'm going to go ahead and rename these. To nitrogen. To nitrogen. So, Go ahead and get the pipe analyzers first. So define. Pipe analyzer 1. Pipe analyzer. Define. Um, 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 volume. Okay. Now we are going to define. I could do this things, but I don't want to. Fine. O2. Copy, go down, paste. Analyzer N. What the names are. O2 pipe analyzer. Yeah. And pipe analyzer. Fine. The screws would be so much easier, but I want to get in the habit of using this and knowing how to use it. That's why I'm doing this so much. Pump O2. Define. Pump. It's going to be a hash. Do all that. I don't like this. Why is this showing here? I think I might just have to name him O2 Pump and call it. Do that. Okay. Defined. So what do I want to do? We're going to do this. So I don't want them to go. The problem is one has a smart canister and the other one doesn't. That's the biggest problem. That is a big issue. I don't have enough time to continue, unfortunately. As much as I would like to, that's going to be it for today. So I appreciate it for you being here. If you like what you have seen today, which was mostly just me faffing about with atmospherics, which sometimes that's exactly what happens, especially when you're trying to learn a new coding language in a game that's decently difficult. Yeah, if y'all like what you see, give it a like, say hi in the comments. I'll see y'all later.